In the dim, hushed silence beyond Neptune, Voyager to our cosmic scout, since the 1970s has made headlines once again, and not for the reasons we'd hoped. A Nobel Prize-winning physicist has issued a dire warning. Voyager 2 has repeated the same kind of error that nearly doomed its twin, Voyager 1. The story feels hauntingly familiar. A routine command is sent, a sudden silence follows. Then the spacecraft's signal vanishes into the abyss. In mission control, engineers scramble as a phrase rarely spoken aloud reverberates through the room. We almost lost our connection. The similarities between this event and past failures are impossible to ignore. Is it a simple technical glitch? Or is this the beginning of the end for humanity's farthest-flung emissaries? As Voyager 2 drifts farther from Earth than any active probe, the margin for error continues to shrink. With each passing day, the stakes climb. Tonight, we uncover what really happened, why the world's leading scientists are raising the alarm, and what we all stand to lose if Voyager 2 falls silent for good. What happened began with a mistake. So small it would be almost laughable if it hadn't nearly severed a 45-year-old connection. In July 2023, a routine command caused Voyager 2's main antenna to shift just 2 degrees away from Earth. In the unimaginable vastness of space, such a minor misalignment was enough to sever a fragile radio link. Data that had trickled back across billions of kilometers suddenly stopped cold. Inside mission control, red lights flashed, alarm systems lit up. And then, those chilling words entered the logs with quiet emotion. We almost lost our connection. This wasn't unprecedented. Just months before, in October 2023, Voyager 1 had also gone silent. A simple heater command had inadvertently triggered its fault protection system, shutting down its main X-band transmitter. Now, to see Voyager 2 vanish for a similar reason so soon after left the scientific community shaken, a Nobel physicist soon stepped forward. His warning was stark. These spacecraft were showing dangerous patterns. The next error might not come with a second chance. For over 10 weeks, the Deep Space Network's massive radio telescopes scanned the sky, hoping for a whisper from Voyager 2. Engineers sent commands, recalculated trajectories, and combed through system logs. The atmosphere was heavy with dread, tinged with stubborn resolve. Every day that passed, the silence felt heavier, said systems engineer Tom Reyes. Humanity was reminded, once again, that out beyond the safety of our solar system, even our greatest achievements teeter on the edge of silence. When a faint signal finally returned, it brought immense relief, but also a new sense of fragility. This wasn't just a technical scare, it was a warning, a chilling echo from interstellar space. The Nobel physicist's words lingered. Voyager 2 had just repeated Voyager 1's mistake. What happened in the void could and likely would happen again. That fragile link, more than a technical feat, is a lifeline. A lifeline to a mission that began in the bold optimism of the 1970s. Voyager 2 launched in 1977, at a time when NASA dared to dream big. Its flight path was the stuff of legend, first Jupiter, then Saturn, onto Uranus, and finally Neptune. Then it crossed the heliopause, the invisible boundary where the sun's influence gives way to interstellar space. Since 2018, it has been the only active probe returning data from true interstellar space, sending back readings on plasma, magnetic fields, and the unknown beyond. Communicating with Voyager 2 is no small feat. Its faint transmissions are only detectable by the 70-meter DSS-43 dish in Canberra, Australia, the only antenna powerful enough for the task. Every exchange takes 18 hours each way, making every command a 37-hour round trip. When you send a command to Voyager 2, you're gambling with history, said DS&N technician Priya Aurora. One mistake takes days to fix if it can be fixed at all. Voyager 2 is still operational, but its days are numbered. Its power comes from slowly decaying plutonium, dropping by about 4 watts a year. Every year, scientists must choose which instruments to shut down just to keep the transmitter alive. Even the smallest error, like that 2-degree dish misalignment, could end the mission forever. Still, this is the price of discovery. Voyager 2's journey is one of both resilience and vulnerability. Each new reading from beyond the heliopause is a reminder of how far we've come, how easily it could all disappear. It's a race against time and silence, Aurora said. And we're running out of both, despite the fragility of Voyager 2. Its twin has already endured similar brushes with disaster. Voyager 1, our most distant emissary, has always been on the edge. In October 2023, a routine heater test intended to protect aging electronics triggered its fault protection logic. The spacecraft did what it was designed to do. It shut down its X-band transmitter. Just like that, decades of contact vanished. It felt like losing an old friend. Engineers had to search through aging documentation, looking for solutions to problems no one had practiced in years. The key was reactivating a backup S-band transmitter, one that hadn't been used since 1981. The gamble paid off. Communication flickered back, but the event underscored something vital. As these spacecraft age, the odds of a minor issue escalating into catastrophe grow. Both Voyagers run on ancient systems, and 1970s logic where safety meant shutting things off, not staying in touch with Earth. That kind of logic is dangerous now. It felt like losing your oldest friend, admitted NASA engineer Rachel Kim. You know they're mortal, but you still hope for a little more time. Each silence isn't just a hardware issue. It's a reflection of human limits, fading institutional memory, fragile legacy code, and a growing fear that one wrong move might be the last. Behind every system is a story of how protection mechanisms can sometimes backfire. Every move the Voyagers make, every antenna twitch, every thruster pulse is governed by the Attitude and Articulation Control Subsystem ACS. Its job is to keep the spacecraft's dish pointed toward Earth. Most of the time, this system works invisibly in the background. But all it takes is one wrong angle, one misjudged command, and the signal is lost. Behind AACS is another safety net, fault protection logic. It shuts down risky components if something overheats or behaves strangely. But risky in this case is based on 1970s design priorities, where overheating was the chief concern. Losing communication wasn't even a category. That oversight nearly doomed Voyager 2 in July 2023. A command sent with a 2-degree misalignment caused the antenna to shift off Earth. Instantly, the spacecraft went deaf and mute. Alarms sounded, scripts were checked, engineers scoured every recent update. In those moments, you're not just troubleshooting a spacecraft, said systems engineer Laura Smith, you're fighting for the soul of a mission. The fix wasn't simple. Every hour in silence raised the risk of the spacecraft falling into an unrecoverable safe mode. The team had to make a bold choice, a full power shout into space, hoping Voyager 2 would hear it. As Voyager 2 drifted farther into the void, the team sent a high-powered correction command on August 2nd. It was a Hail Mary. The dish aimed with pinpoint accuracy. Then came the hardest part, waiting over 18 hours for the signal to reach Voyager 2, and another 18 for any reply. For 37 hours, the team prepared for failure. That waiting is the hardest part, said project manager Suzanne Dodd. Every second, you're imagining what might have gone wrong. Then, finally, on August 3rd, a signal, the antenna had realigned. The mission was saved, relief was real, but so was the exhaustion. It's a huge win, Dodd admitted, but we all know how close we came. The relief couldn't hide the scar the incident left. These weren't isolated failures. A Nobel physicist pointed to a deeper truth. To near losses in rapid succession are not flukes. They are signs of a deeper fragility. The root problem lies in power. The radioactive generators that once seemed eternal now decay, losing for watts each year. Every new year means fewer instruments online and smaller margins for error. Eventually, one fault could push a spacecraft beyond recovery. Mission scientist Alan Wu put it bluntly, we're flying blind, running on luck, and there's no margin left. The Voyager's success is also their greatest curse. Every year they exceed their lifespan is a miracle and an added risk. Even worse, the most fragile component may no longer be the hardware. It's us the people. Institutional knowledge is fading. Code is no longer understood. Each fix becomes harder, each misstep more dangerous. Voyager 2's recent crisis isn't the first, and it won't be the last. From magnetometer heater glitches in 2006 to bit flips in 2010, Voyager 2 has repeatedly danced on the edge. In 2006, a malfunction misaligned instruments. In 2010, a cosmic ray caused a software error. Each time, ground teams patched together solutions from memory, instinct, and hope. Even Earthbound problems have taken their toll. In 2020, maintenance on the Australian DS and dish caused an 8-month blackout. Voyager 2 collected data but had no one to send it to. In 2024, Voyager 1's thrusters clogged. Backup thrusters saved the day, but the risk was real. Each incident adds to a growing trend. As systems age, problems multiply. Fixes become more creative, more fragile. The Voyagers show us what resilience looks like, but also how close we are to failure. NASA knows time is short. Instruments are being powered down. Cosmic ray and plasma detectors have already gone quiet. By the 2030s, more drastic measures will be needed. The choice: preserve communication or keep the science going, not both.